This video is on the objective perform and interpret a two-mean hypothesis test. And this is with population standard deviations known. All right, so your test statistic is going to be a z-score. Right? You're working with the normal distribution instead of the student's t. And this is with technology, right? A calculator to be specific. I'm working with the TI-84 Plus Silver Edition on my computer. And you'll see the TI-83, 84 have very similar functions, very similar features. If you'd like to see more about it, you know, how they do show you step by step how to perform a test for a difference between two means when you have independent samples and population standard deviations known. They show you how to do that pretty, step by step in the more instruction. So if you want to, you can click on more instruction, look at their notes, their videos, their examples, and hopefully those help. All right. So we have a question here. Agricultural scientists are testing a new pig feed to determine whether it increases the pig's weights. The scientists divided a herd of 20 pigs into two random groups, where 10 of the pigs are fed with the new feed, while the other 10 pigs were fed with their regular feed. The following table shows the weight gain after 6 months for both groups of pigs. We're supposed to assume that the population standard deviation of weight gained is 10 pounds for both groups, and assume that the weight gains are normally distributed, right? Now, when they say that, then the sample sizes aren't a problem, right? Because, if it's only 10 and 10, those are pretty small sample sizes. But we're assuming here that the populations are normally distributed, so it really doesn't matter what the sample sizes are. We can still apply the central limit theorem to this, and then do that test for a difference of two population means. So they're saying here, let the weight gained by the pigs fed with the new feed be the first sample, so 1, right? Have all the subscripts of 1. And let the weight gained by the pigs fed with the regular feed be the second sample, right, with the subscripts of 2. At the 1% level of significance, right, alpha is 0.01, is there evidence that the new feed increases the amount of weight gained? And we're going to use the calculator, and they're only asking us here for what would the test statistic be and the p-value for this test, which are given by the calculator. Okay, so before I go into any of this typing stuff in my calculator, I want to establish some of the stuff you do in the beginning of any hypothesis test. So there's a claim being tested, right? Or some belief, some statement being tested by these agricultural scientists, and they're trying to determine if the average amount of weight gained under the new feed, and they said use say that's the first population. Say the average amount, they're trying to test to see whether the average amount of weight gained by these pigs eating the new feed, so mu1, is more than the average amount of weight gained for the pigs eating the regular feed. Right? Is the weight gain increased under the new feed? Now again, another way of saying this would be that mu1 minus mu2 is greater than 0. And if you set up your hypotheses, this doesn't involve equality, so that's going to be represented by the alternative hypothesis that mu1 is greater than mu2, or mu1 minus mu2 is greater than 0. And from this, we'd see it's a right-tailed test. Right? So if you were to find the test statistic, the p-value will be just the area under the curve to the right of the test statistic. And then the null hypothesis is the opposite of this. The opposite of greater than is less than or equal to. But what's going to be assumed here is the equal to part. You're going to assume that the averages are the same, or mu1 minus mu2 equals 0. Pardon me. So we are assuming that the average amount of weight gain for pigs eating the new feed and pigs eating the regular feed are the same. And then decide whether or not we like that later. Am I going to reject this assumption or not? Okay, so I've got the hypotheses established at least, and they also mention the value of alpha, the significance level, is 0.01. So keep that in mind. All right, so I'm going to go back to here, and they give us now they don't give us. There's these two samples, right? Sample 1, sample 2. The pigs eating the new feed, the pigs eating the regular feed, and the amount of weight gained. They don't give us the average. They don't give us really any statistics. They just give us the hard data itself. So you could add them up, divide by 10, get the average, add these up and divide by 10, get their average, and then subtract the averages and do all sorts of stuff. Use the formula to find the test statistic. I mean, we could do all that, but let's have the calculator do some stuff for us instead. So what I'm going to do is enter these two samples, the sample of pigs eating the new feed, the sample of pigs eating the regular feed. I'm going to enter these as lists on my calculator. So again, I got a TI-84 here. You hit Stat, Edit, and hopefully you've seen this by now, right? Me entering lists of data. So down L1, I'm going to list the amount of weight gained by those 10 pigs eating the new feed. So 12 and 42 pounds and 30 pounds. And then when I'm done with this, I'm going to go down L2, down list 2, and enter the weight gains for those 10 pigs eating regular feed. And I'll pop this right back when I'm done. Okay, so I'm back, and you see down L1, I've got now you can't see all 10, but see I'm at spot 11 here. See down L1, I've got the 10 pigs, the weight they gained eating the new feed, and then down L2, I've got the weights that were gained by the pigs eating the regular feed. All right, so I'll get out of here, go quit, and then we're going to perform this two independent sample z-test. All right, because here is the population standard deviations are known, right? They say right here the population standard deviation of the weight gain is 10 pounds for both groups. So that's why it's a z-test and not a t-test, right? So I go Stat, over to Tests, and remember z-test and t-test numbers 1 and 2. Those were for when I was making a test about one population mean with sigma known and sigma unknown. We're going down to number 3. I'm doing a independent sample, right? The sample of pigs eating the new feed and then eating the regular feed. 2 sample z-test, right? And again, it's a z-test because I know the population standard deviations. If I didn't know them, then we'd have to talk about whether or not they were considered, assumed equal or not. Do I have pooled or non-pooled scenario and all that junk, and then I do a t-test. But I just go to number 3, 2 samp z-test. Then they'll ask you, are you given the data itself or just the statistics? Now here I'd go to this area if they gave me, what the sample of the first sample mean and the sample size were, and the second sample mean and the sample size. But they don't give me all that, right? They just give me the data. So I'm going to go to the data area, have that be flashing. All right, what are sigma 1 and sigma 2? What are the population standard deviations? Well, they said, as I highlighted earlier, that they're both 10 pounds, right? So 10 for sigma 1, 10 for sigma 2. What's sample 1's data coming from? What's list 1? Well, just L1, right? That was the pigs that ate the new feed I put those down list L1. List 2 is for the second sample. That was the pigs that ate the regular feed, and I already had them down list L2, right? Frequency 1, now there is no frequency list for these, right? Every single one of these numbers in this list is counted one time. So I'm just going to keep these frequencies at 1. And then this line here is, what does the alternative hypothesis look like? You know, do I have a two-tailed, a left-tailed, or a right-tailed test? And I mentioned to you earlier, this is a right-tailed test, right? The claim here, the alternative hypothesis, was that mu1 is greater than mu2, right? The average weight gain by the new feed pigs is greater than the average weight gain from the regular feed pigs. So I'm going to click on that, the right-tailed test. Then calculate. And see what comes up is, you know, how the alternative hypothesis looks. And it gives me a z-score. Now this z-score is the test statistic. 3.197 or 3.20 if I'm going to 2 decimal. Well, they say round the test statistic to 2 decimal places. So 3.20. And the p-value is also given. And that's the most important line, right? The p-value, because you're then going to compare that to alpha and use that to make a decision about the null hypothesis, and then from there make your conclusions. And the information it gives you below that is about the samples. You know, it gives you the mean of sample 1, the mean of sample 2, the standard deviation of sample 1, the standard deviation of sample 2, and then their sizes. But the most important stuff is, you know, the test statistic and then the p-value. And I've mentioned this before. Remember, p-value is a percentage, it's a probability. It should be from 0 to 1. So you see this 6.93, you're like, oh, that's the p-value, 6.93. No, it's not. I know I've mentioned this in previous videos. You see at the end here it says this e minus 4. This is in scientific notation. That e minus 4 means times 10 to the negative 4th power. In other words, move the decimal place to the left 4 places. So the p-value is really 0.000693. I'd move the decimal place to the left 4 places. And if it's 0.0006, you know, round to 3 decimal places, that'd be 0.001 if I rounded it to 3 decimal places. So back in the assignment here, again, the test statistic to 2 decimal places would be 3.20. That z-score on the calculator there. And the p-value to 3 decimal places would be 0.001, because it's really, again, it's really 0.000693. All right. Okay, and then submit that. Wonderful. All right, and again, you know, read your answer explanations, please. Right. Hopefully, watching me do this on the calculator, it's just entering lists and going to that 2 sample z-test area. You just have to make sure you know what kind of test you're running. You know, right-tailed, left-tailed, or two-tailed. That's half the battle here. And then you see at the end they're saying, hey, the p-value is, you know, 0.001, which is less than the significance level. And remember, when the p-value is less than or equal to alpha, you reject the null hypothesis. And if you reject the null hypothesis, bring my paper up here. Right, if we reject the null hypothesis, you're rejecting this statement. You know, the statement that mu1 equals mu2, you're rejecting that, and then you're accepting or supporting the alternative. And the alternative was the claim that, you know, the average weight gain for the new feed pigs is greater than the average weight gain for the regular feed pigs. You're supporting that statement because you're rejecting the null. So you'd say there's, you know, sufficient evidence to support the statement or support the claim that, you know, or there's enough evidence to conclude that the new feed increases the pig's weight gain compared to the regular feed. Right, so they're explaining all that stuff that you would conclude at the end once you compare the p-value to alpha. And again, hopefully watching me do this, looking at the more instruction if need be, reading the answer explanations when they come up. Hopefully all this stuff is helping you, when you go about doing this on your own. And thanks for watching.